All right, good afternoon, everybody. My name is Jove, and we have our co-host Ken for this week. We're here
Hi
today
there.
to talk about 10x your Databricks investment. So just a quick intro of the two of us. My name is Jove. I'm a solution architect at Ascend here. And Ken?
I'm Ken. I'm a product manager at Ascend.
Awesome. So before we start, let me just take a quick step back and talk about where Ascend fits and spend 2 minutes here. So just a quick summary of Ascend and where we fit in the ecosystem. For your Spark-based pipeline, we can split out the notion of processing and orchestration. On the data orchestration side, you're using some tools probably or products to help manage the cascading transforms required to process data through the stage of pipelines. This is where Ascend sits with our unified data engineering platform over here. I'm not sure if my mouse shows up. So we'll just refer to this as Ascend for today's demo. On the processing side, there are also a number of options, including an Ascend hosted service optimized specifically for orchestration. Given the popularity and power of Databricks, we develop a tight and sophisticated integration and that will help drive even more value from this great product when using it for your data pipeline needs. In the next 20 minutes or so, Ken and I will show you the technical concept behind the integration and a live demo on how this integration works in action. Okay. So let me start first by highlighting the 4 key ways this Ascend integration drives value for our customers using Databricks. And that's also the main topic for today, 10x the value. Your mileage may vary, but first, the Ascend platform is designed to send the smallest amount of work whenever possible to the processing layer. In some data pipelines, this amounts to a tiny fraction of what was being initially sent by the existing orchestration tools. In addition, we also perform data and job deduplication. We'll show all of that in the demo in a second here. Second, we've designed the integration to automate and optimize the configuration spin up and spin down of the Databricks clusters, reducing the admin overhead burden. Third, given the overhead to spin up clusters, our integration layer will also keep Databricks clusters available for new work, so jobs can kick off in seconds, not minutes. And this will also be shown in a live demo in a little bit here. Lastly, for those customers who use a material amount of on-demand instances, I think you're really going to be happy to hear this. Our automated job monitoring and restart capability allows for 100% use of Spot. So over to you, Ken. Let's talk a little bit more about the architecture, and then we'll jump right into a demo after this.
Okay, great. Thanks, Jove. So here is an architecture diagram that explains how Ascend efficiently orchestrates Spark workloads for execution in Databricks. Ascend itself runs either as a fully hosted service or as a managed service in the customer's VPC. And either way you do it, all you need to do to connect Ascend to your Databricks is provide us with a Databricks URL and an access token. And once that's set up, Ascend can start sending workloads to your Databricks environment. And let's see how that works, starting with the Ascend scheduler. So what the Ascend scheduler does is it decomposes larger workloads that are submitted in Ascend and into smaller tasks based on data partitioning. So when the upstream data changes, the scheduler determines the minimum set of tasks that need to be rerun in order to update the downstream. So the first thing that we're doing here is generally pushing way less work into your Databricks platform than you would do if you submit the entire job directly to Databricks. These tasks are also deduplicated, so anything that's been run before will not be rerun. And while it's doing this, the scheduler is also figuring out what the optimal cluster configuration is for running each of these tasks. And so there's no human analysis needed. You don't need to get in there and configure your Databricks cluster. Ascend does that for you. So this cluster configure is passed along with each task to the next step, which is the Ascend Spark Cluster Manager. So when those tasks are sent to the cluster manager, it will look to see if it already has a cluster in Databricks that is suitable for the task based on that configuration information that's passed along. And if so, it'll just go ahead and launch that task immediately on that cluster. If there's not a cluster available, a new one gets spun up automatically, and it's pulling instances from a node pool. So if you constrain that node pool to a certain number of instances, it'll abide by those constraints. And if there's not enough nodes available in the pool, it will basically wait until we have capacity to start up a new cluster. There could also be another cluster already available, already running, in which case it will put that task on that cluster if it's available. So this gets all of our jobs going into Databricks pools, and then once that task completes, the job actually stays running. So unlike most Databricks jobs, when they finish, they would normally shut down and the cluster would shut down. Instead, our job keeps running, and it waits for more tasks to be sent to it. So any job that's not currently doing work in the cluster in its cluster will stay running and accept additional tasks from the Spark Manager. And it only will get tasks that are the right size for the cluster that it's running on. So you don't need to worry about fitting those tasks in that cluster. The cluster manager does that for us. So what happens here is that when it gets an initial task, we already have a hot cluster. We already have a job running there. We pay zero startup costs for all of those additional tasks that we run on that same job. So effectively, we're amortizing that cluster and job startup time, including the Spark startup, across many tasks. And then if the job is idle, if it runs out of tasks and there's no more tasks being sent to it by the cluster manager will actually shut down that cluster after 5 minutes. So what happens if the cluster goes down without the cluster manager making it go down? Well, any task that was running on that cluster is automatically going to get rescheduled by Ascend. And so when it gets rescheduled, the cluster manager will go back and restart a new cluster for it. Or if there's already a cluster running, it'll actually put that on a different cluster, that task. So basically what this allows us to do is support 100% spot instances in the pool, because the most we can lose is one task that was running at the time that the cluster went down, and we'll recover from that spot instance being preempted. So now I'm going to switch it back to Jove, and he'll show you a demo of how this works in action.
Thank you so much, Ken. So as promised, without further ado, let me take the screen over to the demo. So to begin our demo, let me first show how Ascend can do incremental processing automatically, as well as intelligent deduplication, so that we send way less work to Spark. Going back to our first point earlier, we mentioned on the slides. So what I'm showing on my screen right now is the data flow in Ascend that monitors an S3 bucket containing the CSV files for New York taxicab chip records dataset, as well as the NOA weather API. On the far left, we have the read connectors in green to connect to various data sources, such as the S3 API we mentioned just now. Then we have the transform and these red components that are essentially a select query run in the SEN that runs on Spark. These are Spark SQLs. Finally, we have the write connector at the end that we could create as well that sends data over to Redshift. So now the green cap read connector here only contains January and February data right now. As you can see, there's only January and February data right now. With Ascend's data aware system, the data flow monitors for new data arrival in S3 and refresh autonomously to keep every step in this multi-step pipeline fresh with new data. So to demonstrate that, actually, let me step back out again and step into S3. I'm going to add an additional CSV file to S3 that contains chip records from March. And let me go through the screen in AWS here. So then, once this file is uploaded completely, I'm going to flip back to Ascend to refresh the read connector. So in production, the read connector is automated to refresh on the configure schedule. So manual refresh, like what we're doing now, won't be necessary. So let me double check. OK, so it looks like the file is there. So let me now refresh this read connector. So looking at the status indicator for the read connector, we can now see Ascend has detected the new data file and started to propagate the data incrementally through the entire data flow. So now actually let me switch over to Databricks to show a Databricks pool under the cluster we have configured over here. So we see no cluster running right now because we have the min set to 0 for this particular instance pool. So I'll come back here in a little bit to show jobs and clusters once they're created by Ascend. So coming back to the read connector, I would like to explain the details of how automatic incremental processing is possible with Ascend's data aware system. So Ascend keeps track of the every single S3 file in the system that has been processed as a data partition, essentially. And for each file or data partition, Ascend uses the object path as the partition name, so that Ascend can automatically identify which file has been added or removed. In addition, Ascend uses the E tag as the partition signature, so that Ascend can automatically identify which file is changed. So as a result, Ascend is able to just process the S3 files incrementally out of the box by only processing those that are new, removed, updated. Some of our customers are managing millions of partitions a day this way, completely automated. Lastly, we use S3 as an example, but Ascend's data aware system works with any data repositories and any data format. For example, this is a weather. This is a weather data set from NOA API. I could look at the NOA API link over here as well. So this is how we're querying live to the API. So instead of the object path, we simply could use the month embedded in the data itself to identify the data partitions. So as you can see, the partition ID, because it comes from the API, so it's no longer a file name because there's no file. These are essentially data sets coming from the API. So we just use the month information embedded into the data to identify the partitions. So coming back over here, looks like our read connector may have a little bit of a trouble. So let me double check with our, so as we click into it, it just processed. So some of the things I want to mention here, we see 4 out of 5 just now. Actually, we see it here now. 4 out of 5 means 4 partitions out of the 5 partitions have been up to date. So this is yet another indicator in a sense to show how incremental processing is underway. So the number of partitions that's being processed right now is 1. So because we just added one file, the existing files are still there. There's no change. We're not reprocessing them as a result. So after a reconnector completes processing the data, now Ascend will automatically process the new data with the logic and the transform incrementally. So the other thing I want to mention here is in the Send, all Spark jobs running in Databricks is fully managed and optimized by Ascend. So as a result, users only need to provide a SQL logic, as we're seeing here. And Ascend will automatically figure out the rest, such as the driver, executor memories, cores, number of nodes of the cluster. All of those administration work, as Ken mentioned earlier, is now automated by Ascend. That said, Ascend also allows Spark experts to check out the Spark job UI so that they can look at the parameters we use with Spark and offer the ability for Spark experts to provide any overrides if needed. So we talk about incremental processing. The other big reason we can send way less work to Spark is also we have the intelligent dedupe. So let me quickly show that as well. So imagine we're looking at the production data flow now, and I'm going to create my own dev branch, right? If I need to make some changes here. So the way to do that is I just exported the data flow, and I'm going to create my own dev data flow. I'm going to call this dev Jove. This is my personal dev branch. And I come over here, and I import the data flow I just exported. As I do this, I need to provide credentials just to prove that I have access to the data in the data repository. But once I put this in, what you'll notice is Ascend automatically reuse the data behind every single component because there's no changes in the logic. So this is another reason Ascend can save way less work to Spark because Ascend intelligently dedupe the data set on the data layer instead of sending new jobs to Databricks Spark again to reprocess exactly the same data with the same logic. So coming back to our main data flow, and now let's come over to Databricks and take a look here. We should see the cluster is running now. We also should see some jobs. I think it's at the bottom over here. So if we take a look at this Spark worker job, this is pretty typical Databricks Spark job. Engineers can look at the Spark UI as well as the logs. I'm not going to talk too much about that. So what I want to show, however, is the clusters and the pool configurations. So as you can see, there's one cluster running now. And if I click into the cluster, it's pretty standard jobs cluster. But what I want to point out is it's using 100% Spot. So if I come over here, it's actually a 2-node cluster right now. And both of them are Spot instances. And if I were to pull up the pool configuration, we have the pool configuration at 0 to 10. So which means when there's no work, we actually scale this pool down to 0. There's no infrastructure spent at all. There's 0 Spark cluster. And in the on-demand versus Spot, we're using 100% Spot as well. The cluster has been reused as well, so that as Ken mentioned earlier, if there's another job comes in, there's no additional cluster needs to be spun up, but instead we'll continue to reuse the same cluster with way less overhead time. So now actually let me do something. Oh, looks like this is already fully completed as we speak. So that actually concludes the demo. Anything else to add, Ken?
Yeah, I just wanted to. We went back to ascend there, and we saw that everything was up to date, and we were waiting for that first one for quite a while. But that just demonstrates that we didn't pay that same startup cost again as we went and did the further things down, because it reused that cluster. I just wanted to highlight that since these downstream tasks all ran one after another, they were all sent to that same cluster. As soon as one task finished, it picked up the next one and finished out the rest of the work.
Great. The other thing I was actually gonna try is to kill this cluster, because I was hoping it's still processing, but looks like already completed. So even if I were to kill this cluster, it doesn't impact anything now. But the other thing I wanted to mention earlier is if I just kill this cluster, part of Ascend's intelligent layer is to retry automatically. So we actually automatically spin up another cluster to just complete the job. And when that happens, what will show on the screen is you'll see one retry over here. And as we spin up a new cluster will take up the work. That kind of simulates a spot loss scenario, right? Because all these clusters are 100% spot. That's the other point I was going to show, but unfortunately, this is too fast, so I didn't actually get to that. Going to show the actual mechanic of that on screen today.
Yeah, we can actually see that those downstream jobs took a lot less time because we can look at the runtime on the partitions themselves.
Yep. So over here we see 5 partitions, and we automatically do the data profiling so that we know the tips range and fares range. For example, somebody paid $400 in tips in this data set. But what we want to look at is in the job details. As you can see, most of these partitions actually were created earlier today as we're preparing for this webinar. But this new partition at the bottom here actually started just now. So that's, again, to show how we incrementally process the data set. And after we incrementally process the data set, we actually merge them back. So to the user, it's a single unified table. It just looks like a table in the database, where the users can look at the records. The user can actually also use our ad hoc interface to send an ad hoc queries over to these intermediate data sets. All of these runs on Databricks Spark as well.
So we saw that job took 4 minutes to run because that was waiting for Databricks to start up the cluster and the job, and then we should see that the downstream ones should have been quite a bit faster.
Yep.
Right. Yep.
Yep. So we have a timeline view that captures the runtime of all the components, and that's also the basis of establish the baseline for the cost as well. So that's actually pretty much it. Let me come back over here to quickly close this out. First of all, thank you everybody for tuning in today to our webinar to talk about how we 10x the Databricks investment. Again, just to reiterate, the 4 key value areas are: number 1, we send way less work to Databricks Spark because we perform the incremental processing autonomously, as well as we offer out-of-the-box intelligent deduplications. And second, we reduce the Databricks administration and configuration burden by optimizing both the cluster as well as the jobs automatically, so the user doesn't need to provide any configuration to go along with the Spark SQLs, but just focus on the business logic as described by the SQLs. And third, we significantly increase the utilization of the Databricks clusters because we can dynamically reuse the Databricks clusters for multiple jobs. And these are just job clusters. And lastly, we reduce the infrastructure span because we use 100% spot with the Ascend built-in job monitoring and retries. In the production setting, it's actually Ascend make it safe to use 100% spot configuration. So that concludes our webinar today. So I just want to take this opportunity to thank everybody. And again, my name is Jove. I'm a solution architect at Ascend here. And Thank you so much, Ken, joining us today as well.
Thanks, Jove.
Yep, and feel free to email us or reach out if you have any questions. Thank you very much. See you next week.
See you next time.